Okay, I'm going to begin here by going over number 6, one of the distance to the curve problems. I thought I'd do the one with trig because I know that people tend to panic every time they see trig. Okay, but it's no different than any other function. So what is the minimum distance from the cosine curve to this point? And I like to draw pictures. If once you get good at these, you'll realize that you really don't have to draw a picture. You know, there's a clear procedure, and as you do more of these, you're going to start realizing they all look exactly the same. All right, but anyway, here's my picture of the first part of the cosine curve, right, where I start at 1 and I go to, oh, I erased my little dot. So halfway up, right? So over a quarter, up a half. Okay, so there's the point in question. And this point here is pi over 2, which we have to remember pi in terms of radians is 3.14. So if I divide that by 2, I get 1.57. So I'm doing that just to help me get an idea for what the appropriate range would be, or the domain would be for setting my calculator. So there is some point on this curve that is the closest point. So it looks like it might be about right there. So some unknown point xy. Okay, that is the closest point on this curve to this point here in red. So what I'm doing is I'm writing, oh, that should be a straight line. Oh, that's a terrible straight line. So pretend we've got a straight line there connecting the point in red to the point in blue. And we are going to write a formula for the distance of that line. Okay, so our distance formula says take the difference between the x value. So this is why you don't have to have a picture. You can just recognize that it's always the difference of the x values, right, squared, plus the difference of the y values squared, all under the radical, of course. So I'd have y minus 0.5 squared, okay? All of it under the radical. And I would not want to take a derivative of a function like this, and this would be even harder to set the derivative equal to 0. Okay, so that's the last thing I want to do is approach this with the method of taking the derivative, setting it equal to 0. I want to use my calculator, and this will be easy because it's going to be very easy to determine the domain and then do a zoom fit. Because I can tell, I mean, if this is 1.57, like right over here would be 2, right? So I could tell that going 0 to 2, because I want to be a little bit bigger than what I know I need, but I can tell going 0 to 2 would be, you know, I'm expecting to get a value a little bit less than 2. And before I go to my calculator, I have one other problem. The problem that I have, so let's see, let me write down the name of my curve. The name of my curve is y equals cosine x. So the problem I have that I have to solve before I can go to the calculator is that I can't enter a function into my calculator that has both x's and y's in it. All right, but if you are a good math student, then you've gotten good at substituting things for their equals. So we say, okay, well, this y is a problem. I don't like it. Can I substitute for it? And you most certainly can, because y is equal to cosine of x. So we write y in terms of x. So I'm not going to rewrite this whole thing, but when I go to the calculator, cosine of x is going to get put in place. So if you know you're good on the calculator, go ahead and end this video right now. I'm going to go to the calculator, and I want to show you a mistake that I actually made. I actually started this video a few minutes ago, made a mistake on my calculator, couldn't figure it out, said a bad word or two, so therefore I had to stop the video and start it over. I couldn't figure out what I had done wrong. The biggest obstacle to typing things incorrectly is the use of parentheses. And what I realized here, I think I have a couple different parentheses problems. I think I need to go second insert and put another set of parentheses right here so that the whole thing, insert, so that the whole thing ends up being in parentheses. You guys that have that calculator that like pulls the radical up for you, and then you can tell what you're typing into easier. You guys are lucky. Now here is where I made a mistake that I didn't catch right before I started cursing in the last video. Cosine x, the calculator requires me to put a parenthesis around the x. See how I have x minus 5 in parentheses? I don't want that. I want cosine x in parentheses. So I have to hit insert. There we go. And then minus 0.5, and it's that quantity squared. Okay, and then, all right, that should work. All right, so I even was guilty of making the parenthesis problem, typing it in that I warn students so much about. Okay, so I have to have, and sometimes I tell students when you're struggling to enter it, write it out in paper first. So I've got like my, like this, this set and it's closed where it closes, this set and where it closes, and then the set of parentheses at the beginning and the end where it closes. Okay, so now I can go to window, go to 02, do a zoom fit. All right, I better, which is a 0. And I had better, oh, thank goodness. Okay, so that fixed the problem. The last time I did this, I just had an increasing function, which was obviously a clue to me that I had entered something wrong. I knew I had to have a min. Okay, so we go to second, calculate, and we want minimum. And so left bound, right bound. Another thing that you have to remember on the calculator is the y value is the distance to the curve. Okay, so I get an x value, and I like how my calculator marks it off like that. Okay, so I get this x value of 0.418. The distance to the curve is actually 0.44, right? That's the distance to the curve. So I better read what was asked for in this exercise. I'll stop share here and go back to this, and let's see what was actually asked for in this problem. Because sometimes they ask for the point on the curve. All right, this one asks for the minimum distance. Okay, so when I graph, when I'm entering this into my calculator, this is my y. The distance is the y value. So if you recall, we got x coordinate, right? And then we got y coordinate. The y coordinate is the actual distance to the curve. And I believe that was 0.44. Okay. If I wanted the point itself on the curve, then I would take the value of x that I got, right? Which I already forgot what I got for x. I would take the value of x that I got, and then I would have to find the cosine of the x coordinate, right? The cosine of whatever that was to get me the actual point on the curve. Okay, but this question asks for the distance. And so the minimum distance to the curve is 0.44.